All right, guys, are there any questions on the homework before we get started? Questions on 7-1 or 7-3-1? Questions on 7-1 or 7-3-1? 7-3-1? Because it was from Tuesday to Monday? Okay. So, what we're doing today, 7-3-2, is we're dividing two rational expressions. We're dividing two rational expressions. And when we divide rational expressions, we're going to use this property here. We're going to keep the first one the same. We're going to change it from division to multiplication and flip the second. So really, the only difference between division and multiplication is the first main step. The first main step is going to be the only real difference. So when we look at this first example, 7x over 2x minus 10, divided by x squared minus 6x over x squared minus 11x plus 30. When we divide these, we find this quotient. The first thing we're going to do, because we have two fractions, is we're going to keep the first one the exact same. We're not going to change anything. However, we're going to change it from division to multiplication and take the second expression and flip it. We're going to flip it. So the x squared minus 11x plus 30 is going to go on top. The x squared minus 6x is going to go on bottom. And then do the exact same thing we did with multiplication. So really, division is almost exactly like multiplication, except for the first main step of changing it from division to multiplication and flipping the second. Keep, change, flip. Questions on this so far? Questions on anything we've done so far? So now that we've got it to this point here, we just need to factor each of the terms on top and bottoms of the fractions, multiply them together, and then simplify. Now our 7x, because it is a single term, is just going to stay 7x. There's nothing to factor, there's nothing to simplify. Questions? Now the next place I would look at is 2x minus 10. We have two terms here. The degree is 1, so we'd be factoring out a greatest common factor. Now, between 2 and 10, they have a greatest common factor of 2. Because the 10 does not have a variable, there's nothing to factor out there, so the only thing we can factor out of 2x and 10 is just 2. Now, when we factor the 2 out of 2x, we get x. Minus. Factor 2 out of 10, we get 5. So we had 2 times x minus 5.
I'm not touching. I'm not doing
Okay.
anything.
Let's start taking notes. Guys, focus up here. Questions on how we factor the first fraction? Now, when we look at the second one, we have x squared minus 11x plus 30 on top, x squared minus 6x on bottom. So we can pick which one of these two we want to work with. Now, the x squared minus 6x has two terms, and again, we want to look for greatest common factor first. Is there a greatest common factor between x squared and 6x? Well, yeah, so it would be x. Now, because x squared does not have a number in front of it other than 1, there's no number to take out, so we can only factor out the x. Now, we factor x out of x squared, we have x minus. Now, the x in 6x will factor out completely, telling us at the bottom of this fraction here is that going to be x times x minus 6. Now that leaves us with x squared minus 11x plus 30 as the last thing to factor. And as we look at this here, there is no greatest common factor between x squared, 11x, and 30. We know this because x squared doesn't have a number in front of it, so there's no number to factor out of all three. 30 does not have a variable, and that pretty much eliminates everything we could factor out. So we're going to go to our two sets of parentheses with three spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. So it's going to be negative and negative. Now we need to find the factors of the first and third term. Now our factors of x squared, well, the only set we have is x and x. Factors of our third term, factors of 30, there's a few. We have 1 and 30, 2 and 15, 3 and 10. 4 doesn't work, but we do have 5 and 6. Which one of these sets of factors do we want to try first? 5 and 6. What leads us to wanting to try or go with 5 and 6 first? The bottom. Because on bottom we do have x minus 6 in one of the sets of one of these fractions, and the other we do have x minus 5. So if 5 and 6 work, and these are the correct factors, we know x minus 6 over x minus 6 will reduce. We also see that x minus 5 over x minus 5 will reduce. And I'm going to check it off to the side just to make sure these are the correct factors. X times negative 6 would be negative 6x. Negative 5 times x would be negative 5x. Negative 6x minus 5x, negative 6 minus 5 is indeed negative 11, telling us that these are indeed the correct factors. So we've been able to factor all four spots. Questions on how we got to this point here? Now we just need to multiply and simplify, yes? Now on top, monomial terms are already in the front and already together, so really we're just saying that we have 7x times x minus 5 times x minus 6. Let's put them all next to each other, showing that they are indeed multiplied together. Now on bottom, we don't actually have our monomial, our terms outside of the parentheses together, because one of them is 2. And what's our other one? X. Because our 2 times x would give us 2x. They're outside the parentheses, they're being multiplied, so we'll put them together. And it's being multiplied by x minus 5 and x minus 6. Now we just need to see what's in common on top and bottom. So we do have x minus 5 and x minus 5. We also have x minus 6 and x minus 6. And lastly, we have x over x. Because there's only one x on top and bottom, they would simplify out completely. Well, the only thing that's left is what? Step number 2. Interestingly enough, here all the variables simplified out, so we just have 7/2. Questions on this here? Now for this one here, I'm not going to focus too much on the restrictions, but we know that if there's a restriction, it's going to be whatever's going to make the denominator be 0. Any value of x that make the denominator 0, cause the division of 0 would be problematic. So looking at this here, 2 times x minus 5 would make the denominator be 0. Or the x minus 5. If x is 5 and make the denominator be 0, we have to have that as a restriction. Same with our x times x minus 6. Bottom of the fraction, cause the division of 0. But interestingly enough, that x times x minus 5 actually started out in the numerator, yes? but it still causes a denominator of 0. Really, anything that would make this second expression be 0 would be a restriction. Because what we're doing with it is what? We're dividing it by our first expression. So anything that would make that second expression be 0 would also be a restriction. It gives a few more spots where we have restrictions. But we're not really going to focus on that there. Let's look at the second one. 11x over 3x minus 9 divided by x squared minus 5x over x squared minus 8x plus 15. Again, the first thing I would do with any of these here, keep the first one the same, change it from division to multiplication, and flip the second. So the top of this second expression is going to become x squared minus 8x plus 15. The bottom is going to become x squared minus 5x. We keep the first one the same. We change the second one from division to multiplication and flip the second. So we keep it the same, we keep the first one the same, change it from division to multiplication and flip the second. Giving us 11x over 3x minus 9, didn't change. But now we're multiplying it by x squared minus 8x plus 15 over x squared minus 5x. Now we're going to factor and simplify. What would be the one nice expression to factor first? Yeah, 11x. Because, well, it factors to 11x. There's nothing that changes, nothing that simplifies. It's just 11x. There is no way to factor it further. Where would we want to go next? 3x minus 9. Because 3x minus 9, the degree is 1, so there's not going to be multiple sets of parentheses. It's not going to factor that. But we do see that there's a greatest common factor of 3, so we can factor it out. We factor 3 out of 3x, we just get x. We factor 3 out of 9, we get 3. Now, even if it did have multiple sets of parentheses, we would want to factor out that greatest common factor first. It's going to make it a little bit easier to work with. Where do we want to go next? So we can go to x squared minus 8x plus 15. Either one. We'll go top one, x squared minus 8x plus 15. Now there's no greatest common factor between these three terms. X squared doesn't have a number in front of it, 15 doesn't have a variable. So we'll move on to our two sets of parentheses with 3 spaces. The reason we think, or this should work, is because we do have a degree 2, x squared. Now once we have it set up here, we're going to find the sum. Since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Now I want to find the factors of the first and third term. Factors of x squared are x and x. Factors of 15. 1 and 15. 3 and 5. Don't have as many factors as the last one, but I think we know which one we want to go with. 3 and 5. Because if this works, we will have an x minus 3 on top and bottom. Those will cancel. Those will simplify out. And if we check it to make sure, x times negative 5 is negative 5x. Negative 3 times x is negative 3x. Negative 5x minus 3x. Negative 5 minus 3 is negative 8.
Following students within the office: Sean Barnett, Kiana Brown, Destiny Clinton, Bobby Cranford, Tucker Davis, Our Lady Hoyles, Andrew Detweiler, Tristan Hart, Gage Flippo, Gary Carrington, Ryzen Hodge, Dave Hooper, Dave Howard, Alexis Moffitt, Isaac Melke, Tyler Olson, Brittany Payton, Nathan Raquel, Langston Sixkiller, LaShawn Taylor, Braxton Walker, Ben Weaver, Tyson Willerton, Braden Williamson, Brooklyn Williamson, Ivan Willis, Bentley Rice.
All right. Now, as we look at the bottom of this fraction here, x squared minus 5x, most likely we're not going to have two sets of parentheses. We could, because we do have an x squared, but I would look for the greatest common factor first, which is x, yes? And if we factor x out of x squared, we'll have a single x. We factor out the x out of 5x, we get 5. So it's not going to go further from here, because the degree of what's inside the parentheses, it was 2, but it's now become 1. So there's not any way we can go further than that. Questions on how we got this here? Questions on any of this so far? Now at this point here, we do have something, especially in that second set of parentheses, that's similar to the first one, yes? What do we have on top and bottom? X minus 5, yes? Will these simplify? Well, yes. Will they simplify if I rewrite them as just one fraction? Is there anything that's saying I can't simplify it now? That I have to rewrite it? No, if there's something in common, on top and bottom, cancel it out. It will simplify out here. Because especially if we see something in common on top and bottom already, might as well go on and simplify it out. Because if I simplify it here, we get this. If I don't, we're still going to have x minus 5 over x minus 5, which is going to simplify out anyway. All right, guys. Focus it back in. So, any questions on how we got to this last step? 11x times x minus 3 over 3x times x minus 3. So, last thing we need to do is simplify the last few parts. X minus 3 over x minus 3 would reduce. Interestingly enough, because we have one x on top and bottom, it will reduce also. Telling us this is just going to reduce to 11 over 3. Questions on this here? Now, it is not always going to work out that division simplifies to a fraction, simplifies to a single term. It just worked out that way for these last few. Let's look at the next one. 4x over 5x minus 20 divided by x squared minus 2x over x squared minus 6x plus 8. Again, the first thing I would do, especially with division, is to keep, change, flip. Keep the first one the same. Change it from division to multiplication, and flip the second expression. So we're going to put the x squared minus 6x plus 8 on top, and our x squared minus 2x on bottom. Keep, change, flip. I would always do this first just so we keep track of it, we get it set up right, and not try to factor, then go straight to multiplication without changing it. Yes. Now again, just like with the last few, we do have one of our expressions as a single term. 4x, not going to change, not going to simplify, so might as well just go on and put it down. Which one do we want to factor next? 5x minus 20. Now 5x minus 20 has the greatest common factor of 5. And if we factor it out of both terms, we factor 5 out of 5x, we get x. If we factor the 5 out of 20, we're going to get 4. Where do we want to factor next? Top left. Our x squared minus 6x plus 8. Now, there is no greatest common factor between x squared, 6x, and 8, because x squared doesn't have a number. 8 does not have a variable. Now, since the third term is positive, our signs are the same and match the sign of the middle term, the negative and negative. Factors of x squared are x and x. Now, factors of 8 are 1 and 8 or 2 and 4. One of these two has to work. Which one do we want to try first? 2 and 4. Because with 2 and 4, we do indeed have an x minus 4 on top and bottom that's most likely going to simplify out. Now we can check and make sure. X times negative 4 would be negative 4x. Negative 2 times x would be negative 2x. And negative 4x minus 2x, negative 4 minus 2 would indeed be negative 6. So that tells us those are the correct factors. Now that leads us to our last expression to factor x squared minus 2x. And there is a greatest common factor of x in common with those two there. So if we factor the x out of x squared, we get x. Factor the x out of 2x, we get 2. Questions on how we got to this point here? Questions on this here? All right, guys. Focus in. Questions on how we got to this point? Now, up to this point, and especially we would see, okay, x minus 2 over x minus 2 will indeed cancel out, they simplify out. We have the same thing on top and bottom, yes? Now, when we multiply, really, what are we doing when we rewrite it? We're just putting everything on top of both together on the same line. Yes, everything on bottom together on the same line. Yes? Have I just done the same thing? Well, yes, I did it without having to rewrite the whole expression all over again, because that's all we're doing with multiplication. We're just merging everything on top with everything on bottom, which then I can also say, well, I'm going to try to erase that. The x minus 4 and x minus 4 would also cancel. X and x cancels, telling us that it is 4/5. If that makes sense, you understand how to keep those straight. We can do it that way. If not, you want to rewrite it. 4x times x minus 4 over 5 times x minus 4, because once we get here, x minus 4 over x minus 4 cancels. X and x cancels, telling us that we have 4/5. We will still get to the same spot. We will still get to the same answer. It's just a little bit less writing. Questions on any of this here? Now, we can make these quote-unquote harder, but really all we're doing is adding more factoring steps, more factoring processes to it. It's not that the problems are getting harder or more difficult. We're just having to factor more, keep more term strength. So, if we look at this one here, again, first thing I would do is keep, change, flip. We're going to keep the first one, 4a squared minus 1, over a squared minus 4. We're going to change it from division to multiplication and flip the second. So the a minus 2 on bottom is going to go to the top. Our 2a minus 1 on top is now going to be on bottom. Keep the first one the same. Change it from division to multiplication and flip the second. Now the a minus 2 and 2a minus 1 are nice because neither one of them has a greatest common factor. A and 2 on top don't have one. 2a minus 1, no greatest common factor. So they're as simplified as it gets. The degree is 1. There's nothing we can do with it. Now if we look at the first expression, either top or bottom, which one do we want to look at first? The top. 4a squared minus 1. We only have two terms. There is no greatest common factor other than 1. So there's a good chance it's going to have to multiply with two sets of parentheses, yes? Now it is interesting to note that there is no middle term. And we have two terms being subtracted, yes? So there's a good chance it's a difference of perfect squares. As long as both terms, the first and third term, are perfect squares. We can start with 1. Well, what times itself is 1? 1. 4a squared, well, a squared is indeed a and a. What times itself is 4? 2. So really we're saying that 2a times 2a is indeed 4a squared. 1 times 1 is 1, and the signs would be opposite. A squared minus b squared is equal to a plus b times a minus b. A squared minus 4 does not have a greatest common factor. A times a gives us a squared. As we already stated, 2 times 2 gives us 4. So a squared minus 4 should factor to a plus 2 times a minus 2. Now at this point here, we can say, multiply these together. 2a plus 1 times 2a minus 1 times a minus 2 over a plus 2 times a minus 2 times 2a minus 1. So we can rewrite it out. We can rewrite it so that we have the three terms on top being multiplied together and the three terms on bottom being multiplied together. Interestingly enough, there's only one term. Well, two sets of terms on top and bottom. We have a minus 2 over a minus 2. We also have 2a minus 1 and 2a minus 1, leaving us with 2a plus 1 over a plus 2. And that's it. Questions over this here? Yes. We ready for the next one? Y squared minus 9 over y squared divided by y to the 5th plus 3y to the 4th over y plus 2. Again, the first main thing I would do is keep the first one the same. Change it from division to multiplication and flip the second expression. Keep, change, flip. Keep, change, flip. Keep the first one the same. Change the second from division to multiplication. And flip the second expression. So where would we like to start? Y squared or y plus 2? What do you think? Either one. Because y squared is already simplified, yes? Single term. The only way y plus 2 could be factored or simplified is if it had the greatest common factor, since the degree is 1. It doesn't, and there is no greatest common factor. It's just going to say y plus 2. Which one? Y squared minus 9 is indeed a difference of perfect squares. Because y times y is y squared. And what times itself is 9? 3. Y squared minus 9 is going to be y plus 3 times y minus 3. So the difference of perfect squares, once we start seeing, it's going to be nice to know that they factor in the same way every single time. Last one we have is y to the 4th plus 3, or y to the 5th plus 3y to the 4th. Might be a little daunting because we have these high powers, but is there a greatest common factor between them? Well, yeah, they both have y, yes. So that means I can factor that variable y out. Now the question is, how many can I factor out? 4. The smallest exponent attached to a y in that expression is 4. So if I take 4 y's away from y to the 5th, well, it's going to reduce it from 5 to 1. So just y plus. Still have the 3, because we're not messing with the numbers. But if I take 4 y's away from y to the 4th, I take them all away. It's just 3. Now at this point here, we could rewrite it with a single line and simplify. We can multiply together. On top, it's just going to be y plus 3 times y minus 3 times y plus 2. On bottom, we will have the y plus 3. But we also have to multiply the y squared and y to the 4th. Since the first one, y squared, is just by itself, we don't have anything added to it, subtracted to it, just y squared. Our y to the 4th is out front. It is by itself. There's nothing with it. So we will have to multiply those two together. In y to the 4th times y squared, we're multiplying like basis, so we're going to have to add the exponents, which will actually tell us it's y to the 6th. Now let's simplify what's in common. Well, y plus 3 over y plus 3 would cancel, and that's it. So we're left with y minus 3 over y plus 2 over y to the 6th. And that's it there. We don't have to simplify it back. We don't have to remultiply anything out. This is the final answer. We do not have to write that the top is y squared minus y minus 6 over y to the 6th. We do not have to write that. Because really, that's not making it any simpler. It's not any different. They are the exact same answer. We have the answer. No reason to put more work in past. Questions on this here? Questions on anything we've done so far? We can do the next two. There's not anything harder about them than what we've been doing. I want to look at this last piece here. So we want to find the quotient of 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. And again, as we've been doing, we keep the first expression the same. So we still have 6x squared plus x minus 15 over 4x squared. But again, we're changing it from division. We're changing it from division to multiplication. And then we do what? We flip the second, yes? So wait, what is the bottom of this fraction? The bottom of the fraction is 1. Even though we don't say it, we don't write it, it's understood to be 1, yes? Which means the numerator, the top of the fraction, is now going to be 1. And the bottom is going to be 3x squared plus 5x. So even though they didn't write the denominator, the bottom of that fraction in the second, since it's not written, it's understood to be 1. So when we flip it, the 1 goes on top, and our 3x squared plus 5x goes on bottom. Questions on this here? Now at this point here, the two nice things to factor are the, well, 1 and 4x squared. Because 1 is as simplified as it gets. There's absolutely nothing we can do with it. 4x squared is a single term. There's nothing we can do, nothing we can factor. Now that leaves us with the only other two spots that we can factor something. Are 6x squared plus x minus 15 and 3x squared plus 5x. Top or bottom, which one do we want to factor first? Top, 6x squared plus x minus 15. There is no greatest common factor between 6x squared, x, and 15. 15 doesn't have a variable. Now, 6 and 15 do have common factors, but because the middle one is 1x, there's nothing in common with all three. We can find the sign. Since the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Now this is the first time, at least today, we have a number in front of x squared other than 1. So we will need to find the factors of 6. However, the factors of x squared are still just x and x. We don't have to find them together, we can find them separate. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Now our factors of the third term, factors of 15 are 1 and 15 or 3 and 5. Which one do we want to try first? 3 and 5. Do we want to put the 3 with the plus or with the minus? Plus. And then we can check and make sure we got the correct factors. 2x times negative 5, 2 times negative 5 would be negative 10x. Positive 3 times 3x would be positive 9x. Negative 10x plus 9x, negative 10 plus 9 would be negative 1, or negative 1x. Is that the middle term we wanted? No. Yes and no, because we want it to be positive 1x, not negative, yes? So we just have to flip signs. So no, we did not get the correct middle term, but we got the correct number, but wrong sign. We got there, we just had the wrong sign. So to fix the sign, we just need to flip it. And when we flip the signs, 2x times 5, positive 5, is going to be positive 10x. Negative 3 times 3x is going to be negative 9x. 10x minus 9x, 10 minus 9 would give us positive 1 or positive 1x, which is the middle term we wanted. So those are the correct factors. So we had it set up correctly, we just need to flip the signs to get it to the correct sign. Now lastly, 3x squared plus 5x. It is a second degree, so first thing we need to look for is greatest common factor. It has the greatest common factor of x. And if we factor x out of 3x squared, we're actually left with 3x. And if we factor x out of 5x, we get 5. Okay, so we do have 3x plus 5 on top and bottom, yes? Now again, if we wanted to, we can draw a line, simplify and multiply back out. Or, if it helps, we can multiply the top, 2x minus 3, times our 3x plus 5. I can put times 1, but it's the same as if I leave it as just this here. Nice thing about multiplying with 1. On bottom, we're going to have to multiply the 4x squared next. We'll still have 4, but x squared times x is going to be x cubed. We have 3 of them now. And now what simplifies on top and bottom is what? 3x plus 5 and 3x plus 5. Now what that leaves us with is 2x minus 3 over 4x cubed. it feels like something should simplify here, especially having the 2x on top and the 4x cubed on bottom, yes? But again, remember that 2x and 3 are stuck together. They are a single term. If that 3 had been 4, 2, 6, another even number, that would allow us to factor that 2 out of the top, then we could simplify with the 4 on bottom. But questions on this here? Is this really any different than what we did on the previous ones? No, it's just saying that that other denominator is 1, yes? We need to see another example of one of these. All right. We're not worried about that. That's it, 28 through 34. I did put one monomial with dividing, same thing, we just flip it and multiply. That is it.